Let's see binary tree using linked list. Looking at this figure, we will come to know that it is a doubly linked list. Why? Because it has two linked lists, that is left link and right link. Yes. Here, what when it comes to the binary tree, right? Your tree looks like this, right? That is, it is a root left and the right. Say as it is, we have written here root. Here it is a left subtree and here it is a right subtree. This is what your representation of a tree using linked list with the help of doubly linked list. Let's see the types of the binary tree. Types of the binary tree are strictly binary tree, skewed tree. Next one is complete binary tree. Third one is binary search tree, and last one is an expression tree. What is strictly binary tree, or you can say it as a fully binary tree? A binary tree having 2 raised to I nodes in any given level I is called as a strictly binary tree, or you can say it as a fully binary tree. You know that the level is going to start with the value 0. What the strictly binary tree, what you have to remember, at every level, that is at the I level, the nodes must be 2 raised to I. If the I value is 0, 2 raised to 0 means what's the value? 1. If the I value is 1, 2 raised to 1 means what's the value? 2, right? Here the level is 0. 2 raised to 0 means only one node. Here the level is 1. 2 raised to 1 means 2. The same thing it will continues, right? This is nothing but your strictly binary tree. Here the level is 2, right? If 2 raised to 2 means 2 raised to 2 means how much? 4, right? If it is 2 raised to 3 means 2 into 2 into 2, 2 to the 4, 4 to the 8. The 8 trees must be there. This is whatever strictly, or you can say it as a fully binary tree. What the binary tree? A binary tree having 2 raised to I nodes at any given level I is called as a strictly binary tree. Here every node other than the leaf node has two children. Every node other than, these are the other nodes, right? Every node other than the leaf nodes have two children. This is what your strictly or fully binary tree. Then let's move to the skewed tree. What's the skewed tree definition? It is a tree consisting of only left subtree or only right subtree. Yes, a tree with only left subtree is called as a left skewed binary tree, or tree with right subtree is called as a right skewed binary tree. A skewed tree means here you have the root node, here you have the node, and here you have the node. This is known as a skewed tree. Which type of skewed tree it is? All the nodes consisting in the left side, right? This is known as a left skewed tree. Here this is a node and this is a node and this is a node. These are all on the right side, right? So it is known as a right skewed tree. See here, the skewed tree are two types: left sub skewed tree and right skewed tree. And this is what your left representation and this is what your right. Next, what is complete binary tree? It is a binary tree in which every level except possibly the last level is completely filled. See here, this is the last level. The last level may or may not be filled, but it must be filled from left to right, not right to left. See here, this is the level, right? Here it is filled and here it is a left, right? And it is filled. If it is not filled on the right side, it's okay, but it will become a complete tree. Then let's see here, it is filled and here it is also filled, and when it comes to this node, the left side must be filled. See, it is a binary tree in which every level except possibly the last level is completely filled. If the node in the last level are not completely filled, then all the nodes in the level should be filled from left to right. See here, here you have, here what you have to consider. See here, this is not a complete binary tree because it is fully filled. If it is like this, if it is like this, then it will become complete binary tree. Why it is complete binary tree? The last level which must be filled from left to right. Then see here, this is what your complete binary tree. Then when it comes to the binary search tree, what this binary search tree means, it is a binary tree in which for each node say x in the tree element in the left subtree are less than the info of x and the elements in the right subtree are greater than the info of x. 200 or the binary search tree, if we are moving to the left, it must be less than this value. 200 is there, right? It must be less than 150. When it moves to the right side, it must be greater than the 200. When it comes to here 150, here to the left it must be less value, and when it comes to the right it must be greater. This is what your binary search tree, like this. Here it is 10, right? It is right means greater. When it comes to here, and it must be greater. Here it is 10, right? It is left, right? It must be less than the 10. And when it comes to the left, it must be less than the 5. Like this, this is what your binary search tree. Let's see an expression tree. What is an expression tree? An expression tree is a binary tree that specifies the following properties. Leaf is an operand. Operands, you know that which are the operands, C and B, like this. These are the operands or numbers, you can say. Next, root and internal nodes are operators. Roots and the internal nodes are operators. The subtree represents sub-expression with root of the subtree as an operator. See here, this is what the expression. First, which we will solve? 3 minus 2 you will solve. While solving, we have to move from bottom to top. First we will solve, see here, first we will solve this one expression, yes. Afterwards, which one we will solve? We will solve this one. Second we will solve this one, right? Again we will solve this one, that is third expression. Next, afterwards we will move this, yes. For this, what we have taken? 3 and 2. See here, leaf is an operand, right? 3 and 2 are the operands, yes. Root and the internal nodes are the operators. 3 minus 2, yes. Next we will solve the star, right? So 5 is an operand. Next, plus is there, 6. Next here, see here the expression plus. Next here 2 you are solving this expression. Next 3. See here, suppose I am writing 2 star 3 plus 2, yes. Next, divide by 5. Then what happens? Which one to be solved first? 2, 3, right? We will put 2 here and 3 here. These are the operands, and star here. Yes. Next, I have to put the plus here. Yes, the 2 is on the right side, so I will put here 2. Afterwards, what I will do? I will take the division part and I will put here 5. First, which one to be solved? First this one, next this, next this. We are moving from bottom to top. This is what an expression of a tree. How we will solve? Based on the you have already learned the precedence and the associative, right? Based on this, we have to solve. That is on the expression tree. Thank you.